Welcome to ZoomInData, your go-to channel for in-depth data engineering, analytics, and modern cloud technology interview preparation. In this video, we dive deep into the ** top 25 batch versus streaming processing interview questions in Microsoft Fabric for 2025. Perfect for data engineers, analysts, and anyone preparing for Fabric, Azure, or real-time analytics roles. We cover key concepts, differences, use cases, integration of batch, pipelines, data flows, Spark, and streaming, event streams, Lakehouse in real-time intelligence, latency, consistency, scaling, fault tolerance, monitoring, and best practices, all explained in clear, interview-ready technical language to help you confidently ace your next interview. 1. What is batch processing in Fabric? Batch processing in Microsoft Fabric involves scheduled, periodic execution of data workflows on accumulated datasets using tools like data pipelines, data flows Gen 2, and Spark notebooks. It leverages Lakehouse, Warehouse, and OneLake for large-scale ETL, ELT operations, transformations, and aggregations on historical or bounded data. Common activities include copy jobs, notebook executions, and stored procedures for reliable, high-volume data movement and processing. Outputs are persisted in Delta tables, enabling comprehensive analysis and reporting with eventual consistency. 2. What is streaming processing in Fabric? Streaming processing in Fabric real-time intelligence handles continuous, unbounded data flows using event streams for ingestion, transformation, and routing. It routes events to Lakehouse KQL databases or Lakehouse for real-time querying and low-latency analytics. No-code transformations like filtering, aggregation, and windowing enable in-flight processing before destination landing. Backed by Azure Event Hubs, it supports Kafka-compatible endpoints for high-throughput, event-driven scenarios. 3. What are the key differences between batch and streaming? Batch processes finite datasets periodically with higher latency, while streaming handles infinite streams continuously with sub-second latency. Batch excels in complex, resource-intensive transformations on historical data. Streaming prioritizes incremental, low-latency operations on live events. Batch ensures exact consistency via full recomputation. Streaming provides eventual or at least once semantics with replay capabilities. Resource usage in batch is bursty and scheduled. Streaming requires always-on compute for fault tolerance and ordering. 4. When should batch processing be used? Use batch for historical analysis, periodic reporting, large-scale ETL, and machine learning training on complete datasets. Ideal for scenarios requiring high accuracy, complex joins, or compliance-driven recomputation like financial closings. Suitable when data arrives in bulk or latency tolerance allows scheduled runs to optimize costs. Preferred for data warehousing, aggregation, and integration with Power BI semantic models. 5. When should streaming processing be used? Streaming is essential for real-time monitoring, anomaly detection, IoT telemetry, and event-driven alerts. Apply when low-latency insights are critical, such as fraud detection or operational dashboards. Best for continuous ingestion from sources like event hubs, Kafka, or sensors requiring immediate action. Enables proactive decision-making via KQL queries and activator triggers in Lakehouse. 6. How does Fabric support both processing types? Fabric unifies batch via data factory pipelines, data flows, and Spark with streaming through real-time intelligence event streams and Lakehouse. Shared OneLake storage allows seamless data access across batch and streaming workloads without duplication. Hybrid orchestration in pipelines can invoke streaming components or process streamed data in batch. Capacity-based compute scales dynamically for both, with monitoring across experiences. 7. How does Fabric manage latency requirements? Batch latency is managed via scheduled triggers and incremental loads in pipelines, data flows for near real-time needs. Streaming achieves sub-second latency through direct ingestion and in-flight processing in event streams. Lakehouse KQL queries and direct lake mode in Power BI minimize delays for real-time analytics. Autoscaling and throughput configuration balance latency with resource efficiency. 8. How does Fabric handle data consistency in batch versus streaming? Batch ensures strong consistency via ACID transactions in Delta Lake and full recomputation in reruns. Streaming provides at least once semantics with idempotent writes and retention for replay, reconciliation. Delta format in OneLake unifies consistency across modes, supporting upserts and schema enforcement. Hybrid approaches reconcile streaming views with batch for eventual strong consistency. 9. How does Fabric manage resource allocation for batch versus streaming? Shared capacity units pool resources across batch and streaming, with autoscaling for demand spikes. Batch jobs burst compute via Spark clusters. Streaming maintains dedicated event hubs throughput. Pause, resume and throttling prevent contention in multi-workload environments. Monitoring app tracks consumption per experience for optimized allocation. 10. How does Fabric optimize performance for both modes? Batch optimizes via query folding, incremental refresh, and Spark partitioning in data flows, notebooks. Streaming uses batching, early filtering, and windowing to reduce overhead in event streams. Columnar delta, Parquet formats and indexing accelerates scans across modes. Fast copy and polybase loading enhance bulk transfers in hybrid scenarios. 11. How does Fabric handle fault tolerance in streaming? Streaming leverages Azure Event Hub's geo-replication and retention for event replay on failures. Pause, resume and runtime logs enable recovery without data loss. Multiple destinations provide redundant routing for failover resilience. Autoscaling and throttling mitigate overload-induced disruptions. 12. How does Fabric ensure reliability in batch jobs? Batch reliability via activity retries, dependency paths, and idempotent operations in pipelines. Checkpointing in Spark jobs and rerun capabilities preserve progress on failures. ACID transactions in Delta Lake prevent partial writes and corruption. Detailed run history and alerts facilitate quick troubleshooting. 13. How does Fabric manage monitoring for batch and streaming jobs? Centralized monitoring hub aggregates logs, metrics, and durations across pipelines and event streams. Real-time insights track events, sec, backlog, and anomalies in streaming. Capacity Metrics app provides workspace-level consumption and alerts. Lineage views trace data flow for impact analysis in both modes. 14. How does Fabric integrate batch and streaming pipelines? Pipelines orchestrate batch workflows that consume streamed data landed in Lakehouse, Eventhouse. Event streams route to OneLake, enabling batch processing on real-time data. Hybrid medallion architecture refines streaming data progressively with batch jobs. Shared real-time hub discovers streams for downstream batch integration. 15. How does Fabric handle scaling for both processing modes? Capacity autoscaling dynamically adjusts compute for concurrency in batch and streaming. Event streams configure throughput units. Spark clusters scale partitions. Parallel execution and partitioning distribute load efficiently. Quota management and throttling ensure fair scaling across workloads. 16. How does Fabric support hybrid processing architectures? Fabric enables Kappa-like unified streaming with batch recomputation on OneLake data. Lambda patterns combine event stream speed layer with pipeline, warehouse batch layer. Converging views in Power BI merge real-time and historical insights. OneLake shortcuts and direct lake mode unify access for hybrid queries. 17. How does Fabric handle back pressure in streaming? Throttling and queuing slow consumers during overload in event streams. Autoscaling increases resources under sustained pressure. Partitioning distributes load to avoid bottlenecks. Monitoring alerts on backlog for proactive mitigation. 18. How does Fabric manage checkpointing? Spark structured streaming in Lakehouse uses checkpoints for fault-tolerant resumption. Event streams retention acts as implicit checkpoint for replay. Pipeline run history supports stateful orchestration across batches. Delta Lake versioning provides recovery points for batch state. 19. How does Fabric ensure exactly once processing? Streaming achieves near exactly once via idempotent writes and deduplication in destinations. Batch ensures exactly once through transactional upserts in Delta, warehouse. Spark streaming with checkpoints and replayable sources provides guarantees. Idempotent designs and reconciliation handle duplicates in hybrid flows. 20. How does Fabric support real-time analytics? EventHouse KQL enables sub-second queries on streaming data. Real-time dashboards and activator alerts act on patterns instantly. Direct Lake mode streams data to Power BI without import latency. Copilot and no-code tools democratize real-time insights. 21. How does Fabric manage job scheduling? Batch uses time-based or event triggers in pipelines, data flows. Streaming supports continuous or tumbling schedules where applicable. Multiple triggers and dependencies enable complex orchestration. Manual on-demand runs complement automated schedules. 22. How does Fabric support error handling for both modes? Batch routes failures via dependency paths and retries in pipelines. Streaming captures logs and supports custom handling via transformations. Alerts integrate with Teams, email for proactive notification. Reruns and replay recover from transient errors reliably. 23. How does Fabric control costs for batch and streaming? Capacity-based pricing aggregates costs with pay-for-use on active processing. Idle periods incur no charges. Autoscaling minimizes waste. Monitoring tracks CU consumption for optimization and budgeting. Reserved capacities offer predictable pricing for steady workloads. 24. How does Fabric support enterprise workloads? RBAC, sensitivity labels, and purview ensure governance across modes. Git, CI, CD and deployment pipelines manage large-scale ARM. Private endpoints and encryption secure sensitive data flows. High availability and geo-redundancy support mission-critical reliability. 25. What are best practices for batch and streaming design? Adopt medallion architecture with progressive refinement across modes. Use incremental patterns and idempotency for reliability and efficiency. Implement robust monitoring, error handling, and governance from inception. Leverage hybrid unification via OneLake for simplified, scalable architectures. Thank you for watching. If this video helped you prepare for your Microsoft Fabric interview, please give it a thumbs up and share it with your network. Don't forget to subscribe to ZoomInData and hit the bell icon for more in-depth data engineering, analytics, and cloud technology interview prep videos every week. Drop your questions or topic requests in the comments. Let's zoom in on your success together.